We will begin about a new chapter in organic chemistry, that is aldehydes, ketones and carboxylic acid. In that we will first see the structure of this carbonyl functional group. In that, as you see here, this is the structure of this carbonyl functional group. Here the carbon which is present is sp2 hybridized in this carbonyl functional group. It forms 3 sigma bonds, one of which bond is formed with oxygen, whereas the remaining 2 bonds can be formed either with hydrogen or it could be with the carbon itself. Now this bond angle between these bonds is 120 degrees. The unhybridized carbon overlaps with the 2p orbitals of oxygen and it forms a pi bond in this bond structure. The carbon and oxygen here are joined with a double bond, and the oxygen atom here, as you can see, the oxygen atom carries 2 pair of lone electrons which are mentioned right here in the structure. The next bit we will be seeing under this chapter is the nucleophilic addition reactions. We will see these reactions for aldehydes and ketones. Now, as seen, the general expression for this reaction, what is taking place here is that this group of aldehydes and ketones is reacting with some nucleophile, and there is a process which takes place in 2 steps. The first one is a slow process and it results in the formation of a product. That product further undergoes a fast process and gives us the final resulting product. So under this addition, we will see the addition of an hydrogen cyanide. So when this aldehyde or ketonic group, it reacts with an, for example, consider hydrogen cyanide. In that there is a formation of a product called as cyanohydride. Now, as we saw the reaction of sodium hydrogen sulfate reacting with this aldehyde and ketonic group, such reactions are used mostly for separating of these aldehydes and ketones. This is because the product which is formed here is soluble in water and it can be reconverted into its original group by just simply reacting it with a mineral or with an acid. Under nucleophilic addition reactions, we will see the next type, that is the addition of lower alcohols. Now in that, this reaction here gives us a general idea of what is taking place in this reaction. Now when your aldehydic or ketonic group reacts with the alcohols in presence of hydrochloric acid, there is a formation of an acetal which is the final product. But this reaction also takes place in 2 steps, which gives us an intermediate product and finally gives us the formation of an acetal. For an example, if we consider your aldehydic ketonic group reacting with ethylene alcohol here in presence of hydrochloric acid, we get the formation of ethylene glycol ketone. Now because of the plus I effect in this alkyl halide, what is happening here, that this alkyl group here is getting bulky, and it is getting bulky because there is a decrease in the positive charge on this carbon which is present in the carbonyl group, and there is also a decrease in the steric hindrance. Now what is the steric hindrance? This steric hindrance says that this alkyl group is getting bulky due to the effect or due to the approach of the nucleophile what we are attacking that particular alkyl halide with. The next bit we will see in this, under this chapter, is the haloform reaction. In that, consider an example of a group of this ketone containing a methyl group, aldehyde or ketone containing a methyl group, that when it is reacted with a sodium hypohalide, it reacts and gives us salts of carboxylic acid along with a methyl group which reacts with the halogens like CH3X, what is shown here. This X stands for the halogens which could either be chloride, bromide or iodide. So it forms, this carbonyl group has one carbon less than the original carbonyl compound which it reacted with. An example of that is given right here, in which there is a formation of CH3Cl as the end product. Now the oxidization does not affect the double bond formed right here. The double bond is not affected by the oxidization process. The methyl group formed here is converted into the haloform, and hence this reaction forms the haloform reaction. Now if the halogen considered is iodine instead of chlorine, in that case the reaction is an iodoform reaction, and if that iodoform reaction is attacked by a sodium hypohalide, then in that case it could be used for the detection of the CH3 group, which is further used for the chemical reaction.